Welcome to another module in this online course, Strategy and Introduction to Game Theory. So, in the last module, we looked at an interesting example of a game. We looked at the prisoner's dilemma and we analyzed the prisoner's dilemma. First, we looked at the best responses. We looked at what is known as the best response dynamic of the game. And from that, we derived a very interesting outcome of the game, which is the confess outcome, which we also termed as the Nash equilibrium of the game. And now, to continue to enhance our understanding of this concept, let us try to look at some other games which are similar to this prisoner's dilemma game, to see how this game of prisoner's dilemma is applicable in practice. Let us now look at a simple example of two competing firms or two competing vendors or two competing online retail stores, which are trying to compete by setting either high or low prices. So, and we already looked at this example before, let us now try to analyze it. So, let us look at another example similar to prisoner's dilemma. Let us try to understand this. Let us try to understand a real life application of this prisoner's dilemma by trying to look at a market example. Let us try to look at a simple example of a market. Well, we have already looked at this game before, that there are two competing firms or there are two competing stores or there are two competing chains of stores, for instance, right. So, there are two competing firms who have two possible actions to either set a high price or to set a low price. Both can set a high price H or both can set a low price. Both can either set a high price H or both can either set a low price low. And now, if both set a high price, both get high profits, which are, let us say, both get 500 each. So, if both set a high price, both get a profit or utility of 500 each, right. However, if both choose to play, if both set a low price, that is, if both choose the action L, then both get a lower profit or a lower payoff of 250 each. Then both get a lower payoff of 250. Right. So, if both set a high price, both get 500, a payoff of 500 each, both set a low price, they get a payoff of 250 each. However, something interesting happens when one sets a high price while the other sets a low price. Now, the shop or the firm which sets a low price for its good attracts all the market, therefore, captures the entire market and therefore, is able to manage a profit, a higher profit of 750, while the firm which sets a high price does not capture any market, because they are going to go towards the other firm which has set a low price. Therefore, since it does not capture any market share, since it does not have any customers, it is going to end up with 0, let us say, right. So, if one firm or store sets high H while other sets a low L price, firm which sets a high price gets 0, while firm with low price gets 750, since it is able to capture the entire market away from the other firm. Since it captures the entire market share. So, that is what we are saying. So, we are saying that we are trying to model a simple marketplace, a competition between two shops or two retail stores or two chain stores which are trying to sell the same good by trying to, and they have two actions to choose from, either they can set a high price or they can set a low price. If they both set a high price, then they get a higher profits of 500 each. If they both set a low price, both get a lower profit of 250 each. But if one sets a high price and the other sets a low price, the ones which sets a low price captures the entire market. So, it is able to get a profit of 750, while the one which sets a high price does not capture any of the market, and because it does not capture any of the market, it has a net payoff or utility of 0. So, now let us again try to formulate, as we said, the game table is a convenient way to sort of comprehensively summarize this game, comprehensively denote the payoffs of this game and analyze this game. So, let us try to draw the game table for this game, for the simple market game, for this simple market competition between two firms or two online retail stores. And therefore, what we said again is that this game table, it is going to have, well, we are going to have a row player and we are going to have a column player, right. And let us denote the row player by firm 1, the column player by firm 2. Firm 1, that is the row player, can either choose high price or a low price. Firm 2 can either choose a high price or low price. So, as we said, the actions of the row player are listed along the rows, actions of the column player are listed along the columns, right. And if both firm 1 and firm 2 choose a high price, then as we said before, they are going to get a payoff of 500 each. But on the other hand, if both choose a lower price, both choose to set a lower price, then both get a payoff of 250 each. But if firm 1 chooses a high price, firm 2 chooses a low price, then firm 1 gets 0, firm 2 gets a payoff of 750. On the other hand, if firm 1 chooses a low price, firm 2 chooses high price, then firm 1 gets a payoff of 750, firm 2 gets a payoff of 0. So, this is the game table which comprehensively summarizes the game scenario or the strategic interaction between these two firms in the market. Now, again, remember, the way to analyze a game is to look at the best response dynamics. So, let us start by looking at the best responses that each of these firms can play. For instance, now again, to find the best response, we have to restrict one of the firms to one of its actions. So, let us say firm 2 chooses the action high, that is, it chooses to set a high price, then choosing high yields 500 for firm 1, while choosing low yields 750. So, naturally, low is the best response of firm 1, therefore, firm 1 chooses low if firm 2 sets a high price. And remember, the way we mentioned it is by saying the best response of firm 1 for the action H of firm 2 is to choose low, right. Similarly, on the other hand, if firm 2 chooses to set a low price, then we are restricted to the second column. Setting a high price gives 0 to firm 1, while setting a low price yields 250. So, firm 1 is better off setting a low price of 250. So, setting a low price and getting 250, and therefore, the best response of firm 1 is to choose low, right, and this we can also write this as best response of firm 1 to action low of firm 2 is to choose low, right. So, firm 1, if firm 2 chooses the action H, that is sets a high price, best response of firm 1 is low. If firm 2 chooses to set a low price, best response of firm 1 is again low, right. Now, let us look at the best response of firm 2. If firm 1 chooses to set a high price, that is it is restricting the game to the first row, then the best response of firm 2 is again to set a low price, because low yields it 750, whereas high yields at 500. So, firm 2 chooses low, which gives it a payoff of 750. So, best response of firm 2 to the action H of firm 1 is low, and again if firm 1 chooses to set a low price, then low for firm 2 yields 250, while high yields at 0. Therefore, firm 2 chooses to set a low price, which gives it 250. Therefore, best response of firm 2 to low of firm 1 is again low, and that completes the best response dynamic for this game, right. And now, once again, if you go back, you can look at this table. There is one box or one outcome which is special, where the best responses are intersecting, and that is the L box. If you can look at this carefully, again you can see that basically there is a box where the best responses are intersecting. This is a box where best responses intersect. Therefore, this is the Nash equilibrium. This is the Nash equilibrium of this game, right. We said, what is the Nash equilibrium? If you look at the LL outcome, the best responses intersect, that is the best response of firm 1 to L of firm 2 equals L, and the best response of firm 2 to L of firm 1 is L. So, at outcome L, L comma L, each firm or each online retail store or each shop is playing its best response. So, each is playing its best response. So, that is where the best responses intersect, and therefore, L comma L, therefore, L comma L is the Nash and therefore, L comma L is the Nash equilibrium outcome. What is the Nash equilibrium outcome? Remember, we said the Nash equilibrium outcome is where the best responses intersect. So, when both of them, firm 1 and firm 2, are playing the best response, each is playing the best response to the other. Firm 1's choice of L is its best response to L of firm 2, and similarly L of firm 2 is the best response to L of firm 1, and since the best responses are intersecting, therefore, this is a Nash equilibrium. And this simple example involving two players in the market shows us why different competitors gravitate towards low prices in a marketplace, right. this simple example shows us that setting low prices is indeed the Nash equilibrium in a market competition game. So, this simple example shows us that setting low prices is indeed a Nash equilibrium, and that is the reason why when you have different firms or different shops competing, they tend to gravitate towards lower prices, and when they tend to gravitate towards low prices, that is better for the consumer because you have these goods at low prices, and that is how a free market essentially works. So, this sort of a basic rudimentary example shows us how a free market works by illustrating how in a Nash equilibrium these different competing firms or these different competing shops are trying to set low prices to capture the market share, to capture as much of the market share as possible and thereby increase their profits. This is similar to the kind of competition that is now going on between different online retail stores, trying to capture as much market share as possible by setting low prices for similar goods, right. And we also said Nash equilibrium is indeed, there are several other properties of the Nash equilibrium. For instance, we also said that the Nash equilibrium is a self-sustaining outcome. Nash equilibrium is a self-sustaining, the Nash equilibrium or the Nash equilibrium is a self-enforcing, is we also said it is a we also said that the Nash equilibrium is a self-enforcing agreement. What does it mean to say that the Nash equilibrium is a self-enforcing agreement? For instance, let us go back to our game. Let us look at L, L. If both of them, or let us redraw the game again to basically sort of, so as that I can clearly illustrate the concept of a self-enforcing agreement. We have two firms, firm 1 and firm 2, both can set either high or low prices, and high comma high gives 500 comma 500, high comma low gives 0 comma 750, low comma high gives 70 comma 0, low comma low gives 250 comma 250. Now, you can see if both of them, let us say, agree prior to the game that they are going to set a high price, are they going to stick to that agreement? Well, no, right, because firm 1 can deviate from setting a high price to the low price, capture the entire market, thereby increasing its market share and profit to 750. Similarly, firm 2 has an incentive to deviate and increase its profit from 500 to 750. Similarly, if they both agree on H comma L, you can see that basically firm 1 has an incentive to deviate to set a low price. Similarly, if both of them agree on L comma H, you can see that in this scenario firm 2 has an incentive to deviate. Only in the outcome, if they agree on the outcome L comma L, no one has an incentive to deviate, because if firm 1 deviates, it is going to decrease its payoff from 250 to 0. So, that is not going to be possible. And similarly, if firm 2 deviates from L to H, it is going to decrease its profit from 250 to 0. So, that is not going to be possible. So, you can clearly see L comma L is the only self-sustaining, L comma L is the only self-enforcing this is the only self-enforcing agreement, and that is important because in a marketplace firms F1 and F2 cannot collude to artificially set high prices. That is illegal. That is basically termed as collusion, and there are several laws which prevent collusion, or known as anti-collusion laws. Therefore, in the absence of such anti-collusion laws, they cannot have a formal agreement to fix high prices, and informally also they cannot set high prices, because as you see, that is not a self-enforcing agreement. Therefore, the only possible outcome is that they both set low prices, which is the self-enforcing agreement, which is the Nash equilibrium, and therefore all these different competing shops or firms in the marketplace tend to gravitate towards lower prices, which is good for the consumer, and that is how a free market economy or a free market system works, right. And therefore, and this is a simple example of a free market of a competition price war or a competition. So, this is a simple example of a price war, also termed as a price war between two companies or between two firms. We are going to later develop and refine this competition between two firms to make this example slightly more sophisticated and slightly more practical and more closer to a real life scenario of competition between two firms, right. And also let us observe another important point in this game. The other important aspect of this game is that, let me redraw the game again so as to illustrate this clearly, that we have two firms F1, F2, and both either high, low, and you can see the Nash equilibrium outcome is L comma L, where each of them is getting 250 each, right. Now, in this Nash equilibrium outcome, compared to this Nash equilibrium outcome, there is another outcome where both of them can simultaneously improve their profit or payoff. Although it is not an equilibrium outcome, if you look H at H comma H, there is an outcome H, another outcome H, namely H comma H, in which both of these competing shops or both of these competing firms can simultaneously increase their payoff. Therefore, we say that such an outcome compared to, in comparison, in relation, such an outcome is not a Pareto optimal outcome. So, this outcome, this L comma L, is not Pareto optimal. What is the meaning of Pareto optimality? Given any outcome, if there is no other outcome such that both can simultaneously improve their profit or utility or payoff, such an outcome is a Pareto optimal outcome. Given any outcome, if there is no other outcome such that both players, or such that all players, both players can simultaneously improve their payoff. If there is no other outcome such that both players can simultaneously improve their payoff, it is known as Pareto. A Pareto optimal outcome, else it is not a Pareto optimal outcome. Let us go back to the game. Let us for instance, let us look at the game. For instance, if you look at this game, you can see that if both of them choose h comma h, both of them get a payoff of 500 comma 500. They cannot choose a different outcome where both can increase their payoff. For instance, if they choose h comma l, firm 1 is decreasing its payoff from 500 to 0, while if they choose l comma h, firm 2 is decreasing its payoff from 500 to 0, right. So, there is, so outcome h comma h is such that there is no other outcome where both can simultaneously increase their payoff. Therefore, outcome h comma h is Pareto optimal. Similarly, you can argue that outcome L comma h and outcome h comma L are also Pareto optimal outcomes. Try to reason this out for yourself. However, if you look at L comma L, that is where both the firms are setting a low price, this is not a Pareto optimal outcome, because there is another outcome, namely h comma h, where both of them can simultaneously increase their payoff. For instance, if they choose h comma h instead of L comma L, then firm 1 can increase its payoff from 250 to 500, firm 2 can increase its payoff from 250 to 500. Therefore, since there is another outcome through which both of them can simultaneously increase their payoff, L comma L is not a Pareto optimal outcome. Therefore, if I have to summarize, in order to summarize this thing, we look at h comma h. If we look at h comma h, h comma h is a Pareto optimal, h comma L is also Pareto optimal, L comma h is also Pareto optimal. The Nash equilibrium outcome L comma L is unfortunately not Pareto optimal, since there is another outcome through which both of them can simultaneously increase their payoff. Therefore, L comma L, which is the Nash equilibrium outcome, is the only outcome in the game which is not Pareto optimal. In fact, this is characteristic of the games, such as a characteristic of a prisoner's dilemma game. That is, the Nash equilibrium of this game, which is L comma L. In fact, you can go back to the prisoner's dilemma game and you can look at the Nash equilibrium outcome, which is the confess outcome, and you can again argue that while all the other outcomes, deny, confess, deny, confess, are Pareto optimal, the only outcome, that is confess, which is the Nash equilibrium outcome, is not Pareto optimal. So, this is the characteristic of the prisoner's dilemma game. So, this is not a Pareto optimal outcome. Why is it not Pareto optimal? Again, because if you look at it in this market example, both of them can simultaneously increase from L comma L. By choosing h comma h, both of them can simultaneously increase their payoff from 250 to 500 for both of them. Of course, as we saw earlier, it is not a self-enforcing agreement. Although h comma h is a Pareto efficient or a Pareto optimal outcome, as we had seen earlier, it is not a Nash equilibrium, because from h comma h both the players have an incentive to deviate. So, it is very interesting how in these strategic games, because of this competing behavior, because of the sense of competition between these different agents or these different firms or these different shops, they end up ultimately in outcomes which are not necessarily good for either of them. That does not mean that it is a bad outcome. For instance, when such, as we have seen in this example, when these firms are competing, the prices tend to be lower, which is good for the consumers ultimately, right. However, it just means for both of them it is not a Pareto optimal or a Pareto efficient outcome. All right. So, that is an important concept that we have learned today, which is Pareto optimality. Think about that, and Pareto optimality is also another important way to understand and analyze different games. That is, after Nash equilibrium, one can also ask the question if the equilibrium outcome of these games is a Pareto optimal outcome, and sometimes it can be a Pareto optimal outcome, although we have not seen an example. We are going to see some examples of such games in the future, but we are seeing that in the prisoner's dilemma and games such as the market example, which are similar to the prisoner's dilemma, the net equilibrium outcome or the Nash equilibrium outcome is not a Pareto optimal outcome. All right. So, let us end this module here. Thank you very much, and we will continue with the next module later. Thank you.